Assalamualaikum and a good day. We are from Group 2 and we'll be discussing about interval estimation for case 2. Before that, I will be introducing you our group mate. My name is Mulai Shafia Ashraf, and here we have Anis Zakia, Nur Aisyah Shahira, and Nurul Shafiqah. A little bit about the case 2 for the assumption. Firstly, we have the sample is a random sample for non-normal population, and then the population variance or standard deviation is unknown, and the sample size which is less or equals to 30. So we will begin our discussion for Aisyah Shahira. Yes.
We are dealing with a random sample from a normal population n less than 30 and sigma is unknown. Case 1 and case 3 cannot be used. Instead, we make use of the fact that t equals to x bar minus mu over x divided by set n. It's a random variable having the t distribution with n minus 1 degree of freedom. Substitute x bar minus mu over s divided by set n into the probability distribution, which is this one, t. Then we will get the following confidence interval for mu. The sigma unknown cases, we use S sample standard deviation to estimate sigma. We also use the probability distribution t instead of the z distribution. This t distribution accounts for sample S for a smaller size and used to estimate population standard deviation. Area under t distribution looks very similar to z distribution. To read t distribution table, we need two things, which is degree of freedom and upper tail area under the curve, which alpha divided by half of degree of freedom. Based on the information that is used to calculate S sample standard deviation for the types of examples we'll be doing in this discussion, the degrees of freedom will be given as n minus 1. Next, we need divide alpha with the half of degree of freedom, where alpha is level of significance. Alpha is equals to 1 minus level of confidence. So we choose 95% as level of confidence. Then the level of significance is 1 minus 0.95 equals to 0.05. And alpha divided by half of degree of freedom equals to 0.025. I will show you guys how to use table 7 by substitute this one into the TCV formula. So t equals to 0.025 and n is 10 minus 1. So it equals to t 0.025 and 9. So we will use this one to find the value in table 7. The left-hand column down has the degrees of freedom label, while for the top row has upper tail area or alpha divided by half of degree of freedom. Okay, using those two values, we can look up any area under the curve. So we need both degree of freedom and alpha divided by half of degree of freedom. So also, if you look at the last line in the table, it is labeled as infinity, and the value there is correspondent to the same value in the Z table. So we find the value of t 0.025 and 9 from the table 7 with the value is like this one. T 0.025 and the half of degree freedom is this one. The value is 2.262. That's all from me.
Now we will look at the formula for the case 2. If x bar and s are the values of the mean and the standard deviation of a random sample of size n from a normal population, then x bar minus the critical value, which is sub alpha over 2 n minus 1 multiplied by the standard error, which is s over square root of n, is less than mean, which is the population mean, and the population mean is less than x bar plus the critical value, which is t sub alpha over 2 n minus 1 multiplied by s over square root of n, is a 1 minus alpha, which is the 100% confidence interval for the mean of the population. Since this confidence interval formula is used mainly when n is small and less than 30, we refer to it as a small sample confidence interval for mu. Right. So we look at this where we change it to a margin of error, where x bar minus e equals to lower confidence limit. This one. It is lower confidence limit, where x bar plus e is the upper confidence limit. So the difference between them is minus and plus the symbol. So the mu, of course, is the population mean, and the e is margin of error, where the margin of error, we use the formula, which is the critical value divided, the critical value multiplied by standard error, where the critical value must have degrees of freedom, which is n minus 1. Okay, I will be talking about why you have to put the degrees of freedom, because the more when the degrees of freedom increase, it will be close to a DZ distribution. As example, we have here, this is the standard normal distribution, and then we have degrees of freedom. For example, this is where n is equals to 20. So we have this n equals 20, so it's 19, and this is n equals to 21, for example. So it's 21. So if the sample of size increase, it will be close to the Z distribution. So this is the Z distribution, which is the standard normal.
So now let's take a look at example 1. Example 1, a paint manufacturer wants to determine the average drying time of a new interior wall paint. If for 12 test areas of equal size, he obtained a mean drying time of 66.3 minutes and a standard deviation of 8.4 minutes. Construct a 95% confidence interval for the true mean mu. Sample size is 12. 66.3 is sample mean. S is standard deviation, which is 8.4. And alpha, we use the standard alpha, which is 0.05. The formula is x bar equals to E less than mu less than x bar plus E. For the E formula is equals to T alpha over 2, comma n minus 1 times S over square root of n. T 0.05 over 2, comma 12 minus 1. S is 8.4 over n is square root 12. So for the T 0.025, comma 11, for T 0.025, comma 11, we take a look at table 7. For alpha is alpha 0.025, and V is 11. So the value is 2.201. and then we substitute the E value to the formula. $66.3 plus 2.201 times 8.4 over square root of 12. So I already insert the value into calculator and I got 61.0 and 71.6. 61.0 is lower confidence interval and 71.6 is upper confidence interval.
So we will move to example 2. As you can see, the mean and standard deviation of the content of sample of 10 similar container are 10.5 liters and 0.352 respectively. Find a 95% confidence interval for the assuming content. Assume that the content are approximately normally distributed. So as you can see, 10 similar ni adalah N kita and 10.5 liter ni adalah X bar kita and 0.352 ni adalah kita punya sample. Sini kita punya X bar and ni kita punya N. Kita keluarkan dulu apa yang ada dalam ni. Okay, as we know, kita punya formula ialah X bar minus dengan E less than mu plus with marginal of error. Our X bar is 10.5. We minus with our marginal of error, which is E equals to T alpha divided by 2 N minus 1 darab dengan S over square root of N. Then we get T, our alpha is 0.05 divided by 2. Our N is 10 minus with 1. Our S is 0.352 divided by square root of 10. Then we will get 0.25. Ni kita pakai table 7. So 10.5, we minus dengan 0.25 yang kita dapat tadi. Less than with mu. Less than with X bar kita balik, which is 10.5. And then kita tambah balik dengan our marginal of error, 0.25. Then we get 10.25 less than mu less than 10.75. Ni akhir jawapan kita sebab dia nak approximately normally distributed only. So this is our confidence interval. Ataupun nak lagi faham ialah kita punya lower CI which is confidence interval which is 10.25 and upper CI is 10.75. So that's all from us. Thank you.